very good morning to all of you. I hope you all are doing great. You have already written the GATE mechanical exam, my dear. It's a time to take the second chance for XC. You just write in the comment section before starting the session, is my audio video fine or not? And after that, we all are going to discuss, we all are going to practice. Hemang, very good morning. Good morning all. Yes. Hemang, have you written the GATE mechanical? Is it? Okay. So in the first part, I am going to discuss 22 questions of the thermal, my dear, and in the second part, Dheeraj sir is coming with wonderful question of the strength of material. These are also 22. So in this session, we are going to discuss 44 most important questions which may be the expected for GATE 23 XC. Yes, okay, good. So let's start to discuss. This is all about me. We are not going to stop so much here. Let's move. Yes, definitely few of question, few of your friend are having a doubt. They are very much depressed. We have not performed well in GATE mechanical. That's why today in the evening, that will be at 10 PM, my dear, we are going to discuss, me and Dheeraj sir are going to discuss, if you are going to score low in GATE mechanical 23, then what you need to do next. Means there are the number of points if you want to go for the private, or there are the lot of questions. We are going to discuss all these questions in the session, my dear. Don't forget, tonight 10 PM. This is just an important update because few of your friends are very much depressed nowadays. They are calling, they are a little bit depressed. What we need to do, we have invested one or more than 1 year, but again we got nothing. We got not so much of result what exactly they were expecting. So definitely we have just arranged the session like this. I think it will help you. After that, a free workshop for GATE 24, it is, my dear, it will be on 11th of Feb and date will be time will be 7:30, conducted by Dheeraj sir. Yes, on 15th of Feb, rank predictor will be released. You need to register in this BYJU'S exam prep app, my dear, and you get expected rank with the help of this rank predictor. After that, we are going to start the session. First question is on your screen. Sit with the rough notes and my dear calculator. Yes, good morning, good morning, good morning, Ajay. What was your exam, Ajay? Write the answer, chaliye. 1 kg of the ideal gas, molecular weight is equal to X, my dear. Its molecular weight is X. Occupy the certain volume V at a temperature of, Sroth, good morning. Yes, at a temperature of T and pressure of P, my dear. If 4 kg of the another ideal gas whose molecular weight is 2x, double as a molecular weight, is added to the first gas, keeping the volume constant, volume constant, temperature same, volume V and temperature T same as before, then what will be the final pressure? Like it is the volume somewhere like this. I want to know the correct answer, my dear. It is the volume somewhere like this, and in this volume, first of all, a gas at a pressure of P1, my dear, and okay, no issue. Yes, pressure of P1, volume of V1 and temperature of T1, and at the same time 4 kg of the gas. Right now 1 kg of the gas is filled in this chamber, okay, and 4 kg of the gas is filled in the same chamber, is added to the first gas, keeping the volume B and temperature T same. We are going to fill in such a manner that volume and temperature remain same, my dear. Then as before, then what will be the final pressure of this when 4 kg gas is added in the system? Can you please tell me the answer? Ideal gas is there, my dear. Mixing problem is there. Let me ask the question. How many of you are going to write the correct answer? Okay, Ajay, Hemang, Sruth, what is the correct answer in this case? Pressure is P, volume is B, M is mass given to us, R is already given. These all values are given to us. Let's see how many of you are getting the correct answer, my dear. Like in the first case, P1, V1 will be equal to M1 RT1. Is it or not? R1 T. Okay, wonderful. This one P2 V2, it will be equal to M2R2 T, my dear. So in this case, if I'll take the summation of both, then P1 plus of P2, because volume is same, my dear, will be equal to M1 into R1 will be equal to Ry divided by molecular weight of 1 into T plus of M2, that will be Ry divided by how much is the value? This value will be equal to, if I'm not wrong, this value will be equal to M2 into T. So when I'll take the summation of both, that is 2x is added in this case. So this will be the P final, my dear, P final. P final into volume, M is 1 into Ry divided by x into T, and this one is 4 into Ry divided by 2x, like this, into T. So can you please tell me the answer, what is P final into V? That will be equal to, my dear, 3 Ry divided by x into T. So if I'll compare this value, and what is this P1? P1 or V1 will be equal to M Ry divided by x into T. So if I'll compare both, then P1 is this value, my dear, and P final is this value. It is clearly visible that 3P is the answer. Are you getting my point? P final, if I'll compare this and this equation, we are correctly getting that P final will be exactly equal to 3 of the P initial. Answer will be 3 times of the initial pressure. Yes, absolutely. Hemang, your answer is absolutely right. Srot, Ajay, these are a little bit twisted questions. You must write the answer. Okay. After that, very easy question. Internal energy of the thermodynamic system is defined by, write the correct answer, my dear. Internal energy of a thermodynamic system is defined by, Hemang, Ajay, Srut, fast. The internal energy U of the system is defined by, Hemang say V, that is the first law of thermodynamic. Anyone else, Srut? What is your answer, Ajay? Yes, absolutely right. First law of thermodynamic define the, absolutely right. First law of thermodynamic, yes, because define the internal energy as a property of the system. So up to 9, these are the 1 marks questions. Yes. In the polytropic process, that is described by PV raised to n is equal to constant. In this case, my dear, what if the value of n becomes 0, then the process is known as, means slope becomes 0. Line is horizontal on PV diagram. Line is horizontal on PV diagram because the n means slope is 0, my dear. So what will be the answer? Can you please tell me the? Very good, very good. Yes, nice. Isobaric process clearly visible to us. So again in the XC paper, among Ajay and all of you, you need to wait for these type of question. और ये आते हैं. Competition is very low. Hardly 4,000 to 5,000 of students are going to write the exam. I mean, has filled the form. So definitely, number of competition, number of aspirant in the gate XC definitely low, but मैक्सिमम नंबर ऑफ स्टूडेंट आर द मैकेनिकल इंजीनियर्स. ये थोड़ा ध्यान रखना है आपको. और कंपटीशन बहुत कम है. 4,000 ने 4,500 ने तो फॉर्म फिल किया है. नियर अबाउट 70% ऑफ 4,500 इफ यू टेक, देन आप समझ सकते हो कि 70-80% तक ही गेट लिखने जाते हैं. If you perform a little bit better, my dear, you can get the rank under 100. Under 50, you can get the rank. Yes. Just you need to write the answer. Top 9 question of SOM first, if you are going to attempt the SOM, and top 9 question of thermo first, because first 9 question and first 9 question of thermo, these are the 1 marks question and very easy question, my dear. बहुत सिंपल सा क्वेश्चन है, इसमें बहुत ज्यादा फंसने की जरूरत नहीं है. अजय, can I write like this? COP of HP is equal to COP of refrigerator plus of 1. Next, if L1, L2, L3 are the latent heat of the vaporization at the critical temperature of the nitrogen, water and ammonia, my dear, critical temperature we are going to talk about. At the critical temperature L1, L2, L3, these are the latent heats of These are the latent heats of the nitrogen, water and ammonia. Then which of the following is the correct option for you guys? Yes, Hemang, Ajay, I am waiting for the correct answer, my dear. 5 question you are going to write. It's the 5th questions. So up to the 9 question you should not feel any problem, because these all questions are 1 marks question, my dear. Okay, Hemang sir, D answer. Anyone else? It's a D answer according to Hemang. Vikas, what do you say? Vikas, what is your answer? Definitely right answer, my dear, because the point is very clear. If I draw the PV diagram, my dear, then PV diagram is somewhere like this, and at the critical point, latent heat at this critical point is absolutely zero. So either you talk about the water, you talk about this nitrogen or ammonia, my dear, then definitely the latent heat value at the critical point will be zero. It's going to be zero. Is it? So answer is absolutely right. Latent heat for the ammonia is zero, latent heat for the water is zero, and after that latent heat for the nitrogen is absolutely zero. Yes. C for Chennai, D for Delhi will be the correct answer for this question. Let's move forward and see the next question. 1 marks question is again there. New temperature scale at degree temperature. You know very well. Yes, Ajay Kumar ji, Santilal. Nice to see you. You write the correct answer. The question is purely related to zeroth law of thermodynamic. Generally, we discuss the zeroth law of thermodynamic based on degree centigrade and based on the Kelvin. Here, the new temperature scale is introduced, where the boiling point of the water and freezing point of the water is clearly defined, but not in the degree, not on the Kelvin scale or the Fahrenheit or Rankine scale. It is just like a measurement of the temperature. But again, the scale is not like Kelvin or the Fahrenheit, my dear. In this scale, it is clearly mentioned that scale is something new, that is new temperature scale. So at a new temperature scale, it is proposed by a scientist. Then the normal freezing and normal boiling point are marked by the 500 and 100 degree N respectively. Means boiling point is, freezing point is proposed at a 500 degree N, and boiling point is proposed at 100 degree N. Then if the temperature of the system is measured to the 0 degree N, then what will be the temperature? Okay, according to Hemang, it's 125 degrees centigrade. Maybe the right answer. Let's see. Sir, question is very clear for us that here, my dear, we are having 2 scales. One, not 1.25, not at all. At this point, my dear, if I am talking about this degree N, then at this particular point, this is going to measure the 500, and this one is going to measure the 100, that is the boiling point, my dear, and this one is your freezing point. After that, if I'm talking about the degree centigrade, it is measuring the 0 degree centigrade and 100 degree centigrade. Clear? So we know very well, then all the temperature scale are arbitrary. We can write like this: A of degree of C plus of B. From here, if I'll write, when this will measure the 500, then this will measure the 0, my dear. That's why the numerical value of the V from here I can write like 500. Absolutely right. After that, when it measure the 100, my dear, this will also measure the 100. That is A is equal to minus of 4. Okay. After that, if I'll just substitute all the values, good. This is minus 4 degree C plus of 500. At this 0 value, minus 4 degree C plus of 500 degree, or from here we can simply write that T will be equal to 125 degree centigrade. Absolutely right. Sruth, answer is absolutely right. Hemang, right, and Ajay, your answer is also right, my dear. Next question. Question number 7, again 1 marks question. Thermodynamic process for the substance is represented by a constant pressure on PV diagram and constant temperature on TS diagram. Then which of the following process we are talking about? कौन सा process होगा which is having the isobaric process on PV diagram. At the same time, my dear, it is also having the isothermal process on the TS diagram, or you can say TB diagram. Which of the following process you see? Okay, okay. Anyone else? C is absolutely right answer. This is only possible when phase change exists at a constant pressure, because at the constant pressure, when phase change, my dear, temperature also remain constant. So during the phase change, if pressure constant, then definitely your temperature is also constant, my dear. Absolutely right. Answer is Chennai. Question number 8. The rate of heat received by the engine from the source of this one. Like this one is a heat engine. At a temperature of how much? 900 Kelvin. The heat is received by 600 kilojoule per second. This one is a heat engine. It is doing some work, and at a temperature of 300 Kelvin, it is going to reject some heat. If it produces 200 kilowatt, my dear, as the work done, then it is going to reject how much? 400 of kilojoule per second it is going to reject. Now you need to give me the answer that what will be the irreversibility in this process. Actually, this is the question of cycle, not the process. But even in the cycle, there is also the possibility of irreversibility. Yes. So what will be the irreversibility in this case? Can you please write the answer? जल्दी से बताइए. I am waiting for the correct answer. What is the irreversibility in this case, my dear? Irreversibility, we generally write that T0 into ds. No, not at all, Srot. T0 into ds of universe will be 0. And in this universe, there are 3 components. Let me change the color of this pen. Yes. 1, 2nd, and 3rd. 3 components are there. And you know very well, in a thermodynamic cycle, the change of entropy is 0, my dear. Is it or not? So after that, we can write how much is the T0? 300. ds of the system minus 600 divided by 900. cs or ds of the surrounding plus 400 divided by how much? 300. This is 300 minus 2 by 3 plus 4 by 3. Can you please tell me the answer? What you all guys getting, my dear? Irreversibility in this case? Yes. Is it 200? Are you getting 200? Yes. It's not wrong. श्रुत, ये गलत नहीं है. But from where you will get the W max and W actual, this is the point. You can apply the same formula, but from where you will get the W maximum? This is the actual W given to us. Getting my point? This one is the actual W that is given to us, my dear. Okay. Yes, but again your procedure will be lengthy. You can find from Carnot and after that you will take the difference. But again your point will be, or your procedure will be lengthy. So it will be better whenever it is the scope to find the entropy. It is a scope to find the entropy. Yes, it is possible, Hemang. It's not a different thing you can get. But whenever the scope is there, always go with this basic formula of this one. Then it will give you the direct answer. Otherwise, what you will do the same thing. You will find the maximum work done from the Carnot. That will give you the 400 as an answer. And 400 minus of 200, you will also get the 200. So there are 2 different ways. But this, what you are going to talk about for the Carnot cycle, we can get the proper answer, my dear. But for the Carnot cycle, here this formula only valid. This will not be valid everywhere. Only the valid formula for this one will give you the answer, because in most of the case, it is not possible to find the value of the maximum work done until unless these all the parameters are not given. That's why it will be better you will go with the basic formula. Question number next. An engine working on air standard diesel cycle has a compression ratio of 18. Cycle has a cutoff ratio of 1.7. Ratio of the specific heat is this one. Then what will be the efficiency, thermal efficiency of this IC engine? Let me tell you, my dear, this time get mechanical ने थोड़ा बहुत आपको धोखा दिया है. Question are not asked from the topic in thermal. Right now, from there they are these all questions are generally asked. Like in IC engine, at least one question is asked. From the Rankine cycle or steam turbine or compressor, one question is asked. कोई question ही नहीं था. Weightage was a little bit less what we exactly were expecting, but it is not going to happen in XC. Reason 22 questions are fixed in XC. It's not like this that few questions you can just study from the other subject like HMT or anything else. In this case, if the 22 question आने हैं तो आने हैं, that's all. So ऐसा नहीं होगा कि वो इसमें धोखा मिले आपको, because generally when the questions from like from the subject like thermal, theory of machine, strength of material, जब इनसे बहुत ज़्यादा question नहीं पूछे जाते, then at that time you start to feel little bit boring, because most of the time we study these subject in very detail. So the efficiency of the diesel cycle, we are very much aware with this, that 1 raised to r raised to gamma minus 1 into rho raised to gamma minus 1 upon gamma into rho minus 1. If I am not wrong, then I think everything is given to us. Cutoff ratio 1.7, because 1 marks question is there. So at least these all the things are given to us. 1.4 minus 1, rho 1.7 raised to 1.4 minus 1 divided by 1.4 into 0.7. I am very sure you all have got the answer 64.6%. Yes, this is the correct answer. You all have got, my dear. 64.6% is the correct answer. Yes, Hemang. What is your answer, Ajay? Have you got the same answer, Ajay? After that, 2 marks question are starting. Be confident. Write the answer of this question. System with the rigid wall initially at a temperature of T1. It is used to heat source for this heat engine, which reject the heat to the reservoir. So let me tell you, in this case, my dear, this heat is taken from this rigid wall. Okay, no issue. Work is used, and let me tell you, this one is not a rigid, this one is not the infinite wall. That's why temperature will change in this case, my dear. Okay. After that, heat engine, and what is it? That will be the sink temperature is T0, my dear. T0. So first of all, we need to check. Question is quite interesting for all of you. I just want to know, are you going to solve this question or not? Whenever the question like the maximum work recover from the heat engine per unit mass is asked, then there are two things you can do, or you can solve the question. Either you can find the available energy, or my dear, you can discuss, you can solve the same problem with the concept of entropy. Entropy for the maximum work done, entropy of the entire universe must be 0, because you are going to, yes, exactly so because it is a reversible cycle, that's why entropy must be 0. This is one way. This one is one way to discuss this question, my dear. And the second way to discuss this question is also one more, like you can find the available energy, because in this way, when the heat engine is receiving some this temperature, my dear, then definitely its temperature is going to change, my dear. If I'll draw the TS diagram for the source, yes, absolutely right. If I'm going to draw this temperature of the source, then definitely temperature of this one is going to decrease, my dear. Temperature of the source. Are you getting my point? So in this case, what we can do, if we are able to find this scenario, we are very much aware with this point that maximum work done is nothing but available energy, that is also nothing but heat supply minus of T0 into ds of the system, my dear. Are you aware with this or not? T0 heat supply minus T0 Q minus T0 into ds. So again the wall is maintained at T1, atmosphere is maintained at T0. What is the numerical value of the Q? You must know. Can we write from here that the numerical value of the Q will be equal to, per unit mass, will be equal to CV T1 minus of T0. Not the correct answer, not the correct answer. Either B or A will be the correct answer. Hemang. Now after that, what is the change of entropy of the system? I mean, what is the change of entropy of this? What wall is going to reject the, can we write wall is a finite body? Wall is a finite body that is going to T1 divided by T0. This is the change of entropy of the system. Direct answer. You check this. Direct answer, you can easily check this, my dear. Otherwise, you can solve the same problem with the concept of entropy change in a reversible cycle. In the reversible cycle, change of entropy, answer is absolutely A. Yes. In the last question, you are talking about change of entropy. Okay. For the finite body, change of entropy, we are having the fixed formula that for the finite body like rigid wall, yes, I am coming on the point. For the change of this rigid wall or any boundary, if, my dear, it is the example of the rigid, I mean solid boundary or your liquid, then these all problems are known as the finite body. And the entropy change of the finite body is always written as MC ln T final divided by T initial. But when you will do T final divided by T initial, that will give you the negative answer because T final, that is T0 is less. So it will be better. I will just reverse this by taking the minus sign here. That's why it is the simple answer. Okay. B is not the answer. A is the correct answer. Let's move forward. Question number 11. Number of time. Ajay, yes. Okay, there is also one more question. Okay, sir, final temperature. Okay. Final temperature. Are you talking about final temperature will be in between of T0 and T1? Are you talking about this? Is it your question, my dear? कि जो T0 होगा, is it the question that T0? Ajay, let me clear the doubt from Ajay side first. Is it your doubt that final temperature of this rigid ball will be between T0 and T1? Nahi hoga. Do you know why? Because if this one, my dear, is T1 and this one is the T0, if this temperature is decreasing after rejecting the heat, this temperature is increasing after absorbing the heat, then final temperature will be in between of T1 and T0. Absolutely right. But in this case, my dear friend, this one is given T1. This one is given T1, but this one is given, my dear, T0. It means this temperature is never going to change. So again that will reject the heat, and after a certain time when it become T0, then it will stop to transfer the heat, my dear. समझ लो, तब जाके ये हीट को रिजेक्ट करना बंद कर देगा. ये तो चेंज ही नहीं हो रहा है, तो ये T1 कब तक हीट ट्रांसफर करता रहेगा? जब तक T1 की वैल्यू T0 तक नहीं पहुंचती. That's why your wall temperature become T1 will be replaced by T0. At that time your heat will be stopped, my dear. Yes, check very clearly, because in the previous case, my dear, this question is clearly given to us that to reject the heat, reservoir is maintained. Reservoir means if the thermal reservoir is there, my dear, then it is the infinite source or infinite sink of the heat. It can reject or absorb the heat without a single drop of the temperature. That's why T0 is not going to change. Okay. Yes, write the answer of this question. A reversible heat engine is operating between the two reservoirs T1 and T2, where T1 is greater than T2. Which one of the following is most appropriate way to increase the thermal efficiency? Like, if I'll write the thermal efficiency of the heat engine, truth, then my dear, it will be equal to T2 divided by T1. Is it like this? Then in this way, T2 is the lower temperature and or the sink temperature, and T1 is the source temperature. What we need to do, what is the best way to increase the efficiency? Are you sure? Ajay, what do you say, Sroth? Write the answer. Write down the answer, my dear. Okay, AD will be the answer. No. What is the most effective way? Most means सबसे ज़्यादा, and most effective way will be only one, not two. So, sir, if you decrease the efficiency by delta T, okay, decrease the temperature by delta T, and if you increase the same delta T, then in that case, my dear, efficiency will more increase in this case rather than this case. Efficiency will increase in both the case, because in both the case efficiency is going to increase, but in this part, my dear, it is going to increase with fast rate. Ashutosh ji Agarwal, if you want to prove, we are having the proof. How, sir? We know efficiency is equal to 1 minus T2 upon T1. Is it or not? Sir, what will be the rate of change of efficiency with respect to T2? So can we write from here? That will be equal to, my dear, minus of T1. Is it or not? Is it or not? And if I will check what is the rate of change of efficiency with respect to T1, it will be equal to minus plus. This will be equal to T2 divided by T1 square. So if I'll just solve it, I'll get the answer like this, that it will be written like 1 by T1, my dear, into T2 by T1. So if I'll compare this value and this value, then this rate is same, but this is less than 1, my dear. So rate of change of efficiency in the second case is less than rate of change of efficiency in first case. Getting? Sir, this term and this term is same in both cases, but this bracket term is less than 1. That is going to reduce this term also. So the rate of change of efficiency in second case is less than rate of change of efficiency in first case. So that's why increasing idea is not good. If you are talking about the most, decreasing idea is the best thing. D is the correct answer. Ashutosh, absolutely. Because is your point clear, my dear? आपका एक छोटा सा doubt था. Is this point clear to you? Good. Let's come to the question number 12. Wonderful. Ajay, maximum of you will make the mistake in this question. Even the question is very easy, but maximum of you will make the mistake if this is NAT type question, my dear. This is NAT type question. Maximum of you will make the mistake in this question. Bilkul, because question number 11 we are going 12 we are going to discuss. 10 more questions are left, my dear. After that, Dheeraj sir is coming with the strength of material. 22 questions we are going to discuss in today's class from thermal. 22 plus questions will be discussed in the same class related to strength of material. Van der Waals equation, you all know, my dear. P plus A by V square V minus B is equal to RT, my dear, right? So in this case, R and T both are given. Only one question I just want to verify from your side. If you are able to write the answer of this question, my dear, tell me very honestly, sorry, A, 0.0687 divided by 0.4 raised to square. 0.4 minus B is 0.00657 is equal to R 0.187 into T is equal to 200. Tell me very honestly, how many of you have used volume as 0.4 in place of 4? अगर आपने ये फॉर्मूला यूज किया है, 0.4 you have used in place of this, because in this case, my dear, volume is given as 4 meter cube and mass is given as 10 kg. If you are using this formula of 4 directly, you are 100% getting the wrong answer. गलत आंसर आएगा. Do you know why? Because in this van der Waals equation, just on these points, you need to focus, you need to think very clearly. Otherwise, इन्हीं सब चीजों में आप maximum time गलतियां करते हो. So, because in this van der Waals equation, my dear, this is specific volume, not the total volume. That is 4 divided by 10 is equal to 0.4 meter cube per kg. If you have just written this value, then and only then you will get the right answer. 94.63, absolutely right. Ajay, honestly, have you done this already? Or you have just corrected it? Hemang, I think आपने तो पहले आंसर दे दिया था. That's why you have done this point very correctly. Very good. Ajay, absolutely right. Bikash, what is your answer, my dear? Chaliye, let's move forward. See the question number 13, because after that we are going to discuss 2 marks questions. Then all the questions are the numerical type of question, my dear. Definitely already done initially. Sir, unit of A. Yeah, it is meter raised to 6. Absolutely right. It's a meter raised to 6. Absolutely right. Unit of A is absolutely right. Yes, Ruth. Air at a pressure of this 86 kilopascal and the specific volume is also given, heated at a constant pressure. Air is assumed to be a constant specific heat. If R is given, ratio is given, then change of the specific enthalpy you need to find. For these type of question you have to wait in the exam. इन सब क्वेश्चन के लिए वेट करना है एग्जाम में. ऐसा नहीं कि आते नहीं क्वेश्चन, बट प्रॉब्लम ये है बहुत सारा टाइम कहीं और वेस्ट कर चुके होते हैं. बहुत ज्यादा टाइम हम कहीं और वेस्ट कर चुके होते हैं, इसलिए हम फंस जाते थे. क्वेश्चंस आते हैं. यस, टेल मी द आंसर. P is given, specific volume is given, R is given. Then from the ideal gas equation we are having one important point. PV is equal to RT, my dear, or temperature will be equal to 86. Volume, specific volume is 1 divided by R is equal to 0.287. That is the value of temperature in Kelvin. After that, the change of enthalpy we know very well. That change of enthalpy is equal to C into delta T, or it is equal to gamma into R divided by gamma minus 1 into delta T is equal to T2 minus of T1. So you will substitute all the values. 1.4 from 287 point divided by 0.4, T2 is equal to 627. $900 minus of what T1 we have got, my dear. हमारा T1 कितना आया था? What was the value of the T1? Can you please write the answer? 86 divided by 0.287. $299.65. Yes. to 99.65, then we get the answer A. Absolutely right. That is 1.104 is absolutely right. Good. Wonderful. Question number 14th. Otto cycle has a compression ratio 4. Compression ratio of the cycle is changed to 6. Ratio of gamma is equal to this one. Then what is the percentage increase in the thermal efficiency? I think one of the easy question. One of the easy question for you guys. Is it or not? A air standard Otto cycle has the compression ratio of this one. Compression ratio is changed to this one. Then if time management must be very proper in this case, my dear, what is the efficiency of the first one? It is equal to 1 minus 1 divided by 4 raised to 0.4. What is the efficiency in second one? It is 1 minus 1 divided by 6 raised to 0.4. So it is efficiency in 1, efficiency in 2, my dear. So if I'll solve the difference, can you please tell me the answer? 4 raised to 0.4, 1 divided by answer, 1 minus answer is 42.56. Second, 6 raised to 0.4, 1 divided by answer minus answer, 51.16. So if I'll take the difference, $20.2, yes, exactly the right answer. Exactly, we are getting the right answer. That is 20.2 is the correct answer. Absolutely right. Yes, Ajay, absolutely right. Hemang, absolutely right. And let me tell you, my dear, unfortunately, if your gate mechanical was not good, even if you are working hard, you have just worked hard, my dear, और अभी भी आप उतना टाइम इन्वेस्ट करो, आपके सारे आंसर आ रहे हैं, इट मीन्स बहुत ज्यादा देर तक आपको एग्जाम परेशान नहीं कर सकता. There are a lot of exam yet to come, like BARC exam yet to come. After that, ISRO is yet to come. HPCL definitely, and then even the next week also there is also exam, my dear. So definitely you need not to worry so much. अगर आपने work किया है, बेकार नहीं जाने वाला. हिरेन, good. If you have worked hard, तो बेकार तो नहीं जाने वाला, because this time you are going to give the answer. So again, sometime it may be the mistake, because let me tell you, I don't know what you have done in production, because I'm not so much aware with the production part, but with all the other part, I can say one thing, that if you have not attempted well, then there is only one reason. Question were little bit twisted, and in most of the question you have done only the silly mistakes. इधर उधर की गलतियां की होंगी. Like in few question it was asked what is the correct answer, you have written the wrong answer. It was asked in the pure substance question, what I have seen. One was like this diffuser question. Even the area was increasing, but again you think area increase, velocity decrease directly as per the concept of the fluid mechanics. But when you will solve this question properly, then you will get the wrong answer. So again ये सब छोटी छोटी silly mistakes ही हैं, इन्हीं को इंप्रूव करना है, और ये बार बार बहुत ज्यादा टाइम तक आपको परेशान नहीं करने वाली है. बी कॉन्फिडेंट. क्वेश्चन नंबर 15. यस, इन अ मिक्सचर ऑफ 3 gases, nitrogen, oxygen and methane is filled, molar mass of O2, N2 and this one is given to us, then what will be the mass fraction? Like if in this chamber, my dear, 3 gases are filled, O2, N2 and after that CH4. Then you need to check what is the mass fraction of this one. Then mass fraction M1 will be equal to, M1 means oxygen, 0. N into molecular weight is the mass, 0.1 into how much is the molecular weight of oxygen? Oxygen 32. That is 3.2 kg. What is the mass of N2? Write the answer fast. 0.1 into N2, my dear. Is it 28? 2.8. And what is the mass fraction of CH4? It will be equal to how much? 0.8 into 16. 12.8. So mass fraction of O2 you need to check, or N2. N2 you need to check, that is 2.8 divided by 3.2 plus of 2.8 plus of 12.8. You are getting the answer like 0.148. Absolutely right. C. बिल्कुल सही आंसर. Absolutely right. अजय हेमंग बिल्कुल सही. Next question. A particular gas sample is initially maintained at this volume of this one, pressure of this one. It is compressed during the quasi-static process following this relation. Final volume become this, then what will be the magnitude of the corresponding work done? This similar question, let me tell you, is asked in XC exam. कुछ क्वेश्चन इसके XC के भी लिए हैं, so that you can correlate that these are not the question like mechanical what we write, सिर्फ mechanical से उठाए हुए नहीं, क्योंकि कुछ questions XC के होंगे, तो you will get the clear cut idea that these type of questions are generally asked, my dear. Very easy question. There is a process P1 V1 P2 V2 raised to n raised to n. How much is the P1? 100 into 600 square will be equal to P2 into 200 square. So the value of P2, my dear, it will be equal to 3 times, it will be equal to 900 kilopascal if I am not wrong. Is it or not? 900 kilopascal. P2 is known to us. Write the next answer. After that, let me tell you, this is already given in centimeter cube and kilojoule question is asked. What is the correct answer? Write the correct answer in this case, my dear. 16th question I am going to discuss. After that, 5-6 questions are left. After that, Dheeraj sir is coming with wonderful questions of strength of material. You guys need to attempt these all the questions. And in this way, at least one of the question paper you solve that is related to XC, in which we are taking strength of material and thermal as a optional subject, my dear. What is the answer? Ajay, Hemang, Hiren. Are we not writing after that that work done in the polytropic process will be equal to P1? P1 is how much? 100. V1, my dear, this 6000 minus P2, how much? 900. 900 into 2000 raised to 10 raised to minus 6 divided by 1. Divided by 1. Yes, Surut. There is no point to write the formula. Write the answer. कोई मतलब नहीं है फॉर्मूले का. There is no meaning to write the formula at all. So yes, 1 2 3 1 2 3 1 2 3 1 2 3. So it will be equal to 0.6 minus, it will be equal to 1.8. Answer is minus 1.2 kilojoule is absolutely right. Yes, work is done on the system, right? Work is done on the system. So in this case, you will write the answer minus 1.2. Okay. Next, little bit tricky question for you. Little bit tricky question for you, my dear. Let's see how many of you are getting the answer in this case. Maximum of you are not able to solve this question. अब जैसे ये थोड़ा सा ट्रिकी क्वेश्चन आ जाता है, आप वहीं पे घूम जाते हो. थोड़ा सा भी ट्रिकी क्वेश्चन हुआ, आप वहीं पे घूम जाते हो क्वेश्चन में. In this case, what is it's given, my dear? In this case, it is given TCP raised to TP under the isothermal process is numerically equal to T into d square V upon dt square at isobaric process. It is also given that alpha is also equal to 1 by T, that is iso baric, that is also given as isobaric thermal expansion coefficient. In these type of question you just twist. अब घूम जाओगे यहां पे. Anyone? If you are aware with the basic concept, you are not going to make a single mistake in this question. अगर आप बेसिक कॉन्सेप्ट से अच्छे से अवेयर हो, बिल्कुल भी कहीं से कहीं तक गलत कर ही नहीं सकते. Anyone? Sir. If you are going to skip this question, directly write in the comment section that we are going to skip this question, sir. Okay, D is the answer according to, okay, B is the answer according to Ajay. Hemang said D is the answer. Let's see. Sir, we know very well that isobaric thermal expansion coefficient is also written like this, 1 by V into dV over dt in pressure constant. We are also aware with this formula. So can we write from here that dV over dt, my dear, in the isobaric process, it is also equal to V over T? It is or not? It is also equal to V by T. Agree or not? Yes. After that, if I'll do this differentiation, again because square I need to know, then T square V divided by T dt square in isobaric process, that will be equal to denominator into differentiation of B, that will be dV over dt in isobaric process, minus V into differentiation of T is equal to 1 divided by T, my dear. Is it or not? If I'll substitute the value of this dV over dt from here, then it will be equal to V divided by T minus of V divided by T. If I solve it, then V minus V becomes 0. So in this case, this numerical value is 0. What will be this total value? Is also 0. Answer, Ajay? Answer is B or D. B for Bombay is the correct answer, my dear. Okay? B for Bombay is the correct answer for you guys. Correct. Good. Wonderful, Ajay. Question number 18. A closed system containing 8 kg of the gas undergoes an expansion process following the relation of this one. Initial and final pressure are given to us, while the initial volume is given to us. Specific internal energy is also decreased by this. Then what is the heat transfer? I am very much aware with this question that you all guys are going to solve this question. What you will do, first of all, you will calculate the final volume. Initial volume is given. From this polytropic process, my dear, you will get the value of the final volume, if I am not wrong. Is it or not? You will get the final volume. What is the final volume you are getting? Can you please write in the comment section? After that, what you will do, you will get the work done. So we could simply say in the isobaric process, then the differentiation of it. Okay. Are you talking about this? That in the isobaric process Cp remain constant. You want to say like this, but you can't say because Cp is a constant only under lot of assumption. This is the real relation given to us. उसने relation ही हमको ऐसा दिया है कि आपको calculate करना है. Because when we say that Cp is equal to constant, then this is just an assumption. In reality, Cp is the variable with respect to temperature. With respect to temperature, if it is variable, then definitely it may change, my dear. Getting my point? So हमने वो माना है Cp is constant. Getting? That is just assumed. Yes. Write the answer. After that, what is the work done, my dear? Work done will be equal to P1 V1 minus P2 V2 divided by N minus 1. P1 V1 already given to us. How much? 1 megapascal. I mean 100 kilopascal into 1 minus of 5 into V2. Please tell me the value. What is the value of V2 you all guys getting, my dear? What is the value of V2 you all guys getting? स्रोत कोई आंसर निकाल के लाओ. आंसर तो दे ही नहीं रहे हो. फॉर्मूला लिख के कभी कोई सॉल्व नहीं हो सकता एग्जाम. फॉर्मूला सबको याद होते हैं. Whenever you are not working on the calculator, working on the pen and notes, you can't do anything. कुछ नहीं हो पाएगा. फॉर्मूला लिखने से you can't do anything. Yes, what is the value of V2? V1 is 1 raised to 1.2 into 100,000 divided by 5 kilopascal. Na? Yes, raised to 1 divided by 1.2. The answer we are getting yes. Okay, V2 is 82.7. So this is 82.7. And what is the numerical value of the work done we are getting? The work done in this case, H per Shruth, it is 2.9. Is it the right answer? It is 2.9 kilojoule. When you solve, you get your mistake that you have written kilowatt. Kilowatt is absolutely right, wrong unit. Even the answer must be in kilojoule. In these small slim mistake, you will get the idea kahan galti ho rahi hai. Is it the right answer? 82.7 into 5 and 1000 minus of answer divided by 0.2. Is it not the right answer? We are getting 2932.5 kilojoule. Yes or no? No, it is not the correct answer. We are getting 2932 as a correct answer. After that, what is heat? Heat, internal energy, change of internal energy is also decreasing by 8 into 40, that is 320 kilojoule, my dear. So what is the heat supply we need to calculate? That is decreasing, that's why minus. So answer will be equal to 320, that is 0.5 minus of 2, 1, and this will be 6, and this is the answer, my dear. Why it is coming 2 point? I'm not getting this point. Why it is coming 2 point something? Because it is given in megapascal, na? It is given in megapascal. Yes, exactly, Manas. Very good. Yes, Manas. This is the right answer. 2612.5 is the correct answer. Bilkul. Absolutely right, Hemang. Question number 9. Saturation pressure of the water at 5 degrees is this one, latent heat of the vaporization is this one, gas constant is this one, and saturation pressure at the 10 degree given by. Okay. Do you know very well? आपको थोड़ा सा आइडिया आ रहा है किसका क्वेश्चन होगा? एनी वन ऑफ यू कैन टेल मी द आंसर. एक क्वेश्चन होगा किसका? Can you please tell me the answer? This question is related to with which concept, with which formula this question is going to solve? Okay, good. Which formula this question is going to solve? Any one of you can tell me the answer, my dear. Can any one of you tell me the answer? Saturation pressure of water at 5 degrees is given to us. This one. Latent heat of the vaporization is also given to us. Gas constant is given to us. Then the saturation pressure at 10 degree will be given as. Is it not the question of Clausius-Clapeyron equation? Five degree given, latent heat is given, gas constant is given, temperature is given at other place, my dear. Are you not getting the question with the help of this Clausius-Clapeyron equation? Are you aware with the Clausius-Clapeyron equation? साइक्रोमेटिक का क्वेश्चन नहीं है. Are you aware with the Clausius-Clapeyron equation? Okay. Okay. Anyone? We are also having two formula of Clausius-Clapeyron equation. Are you solving? Should I give you the time? Okay. Are you solving now? Very good. Great. 1.2292 is the right answer. How, sir? We know very well. When we write the differential equation in the integration term, that is completely written by latent heat divided by R 1 by T1 saturation minus 1 by T2 saturation. All the values are given. Latent heat of the vaporization is given, sorry, T2 by T1. Vaporization is given. What is P1 is given? P1, where is it? P1. This 0.8725. Have you solved like this, Hemang? P2, I need to calculate. What is the latent heat? This one. 2489.1 divided by R 0.4615. What is T1, T2 will be in Kelvin, my dear. T2 is this one. 2, this value. T2 is 283 minus of 1 278. When we solve, we'll get the right answer. P2, you are getting 1.22, 9 kilopascal is the correct answer. Yes, I think you are aware when we integrate the Clausius-Clapeyron equation, then we get the answer in this term that ln P1 by P2 will be written by latent heat at the pressure will be equal to 1 by T2 by T1. Yes, you have used the same formula if I am not wrong. Good. Yes, answer is absolutely right. 1.2292 is the correct answer. Good. Only 2 questions are left. After that, Dheeraj sir is coming with a strength of material. Important question related to SOM he is going to discuss. Yes, only 2 questions are left, my dear. Question is little bit lengthy when you will read, but again when you will solve it, it is quite easy, my dear. The turbine inlet condition of the Rankine cycle as given 10 megapascal and 500 degrees centigrade. Inlet condition, okay. Inlet condition of the turbine is given to us. Very good. If I'll draw the TS diagram, then let's see what exactly this question says, my dear. Inlet condition is 10 megapascal and 500 degrees centigrade. Why the condenser pressure is also given to us. So this is the condenser pressure and this is the turbine pressure or the boiler pressure, we can say. The enthalpy and entropy at the 10 kilopascal is also given to us. This one. Respectively, why the enthalpy and entropy of the vaporization at 10 kilopascal is given to us like this and this, my dear, respectively. The enthalpy and entropy at the inlet of the turbine is also given to us, this and this one, my dear, respectively. Condenser outlet of the condenser is saturated liquid, means this point is very clear to us, okay. Outlet of this one, then condenser outlet, neglect the pump work, find the thermal efficiency. What we need to do, my dear, in this case, this is 1 to 2 is the boiler, 2 to 3 is the turbine, 3 to 4 is the condenser, my dear. Okay. So what we need to do, first of all, we need to find the work done of the turbine. Is it or not? First, we need to find the work done of turbine, that is H2 minus of H3. After that, we need to find, my dear, heat rejection in the condenser. That will be equal to H3 minus of how much is the value of H4. After that, we need to find the value of the heat supply, that is equal to WT plus of heat rejection. Is it or not? And in the final formula, we get the answer, that is turbine work because pump is neglected divided of QS. Sir, follow all the formulas. For all the formulas, how much value I need to know? I need to know what is the value of H2 enthalpy at the inlet of turbine. Sir, what is this value? My dear, H2 is equal to how much? 3375.1. Is it or not? After that, H4 at this point, at 10 kilopascal, what is the saturated enthalpy? H4, what is it? 191.8 kilojoule per kg. Sir, can you please tell me what point is only left so that we can get the answer? कौन सा point सिर्फ दिया हुआ है, अब नहीं बचा है, उसको अगर आपको मिल जाए तो आपको डायरेक्टली आंसर आ जाएगा. That point is H3. Means what is the value of enthalpy at this point, my dear? What is the value of enthalpy at this point? You will be easily get the enthalpy if you know what is the dryness fraction as it. Because by chance अगर आपको ये लग रहा है कि यहाँ पे saturated vapor पे आके मिल गया, it may or may not be. You need to know that it is exactly matching, crossing or within the dome. जब तक ये नहीं आएगा तब तक क्वेश्चन गलत होते रहेंगे. So in this case, to calculate the value of H3, sir, one very fundamental concept is known to us, that S2 will be equal to S3. S2 enthalpy at 2 point, my dear, that is equal to 6.5995. S3 enthalpy at the outlet of turbine, that is SF3 plus of X SFG3. So what is it? 6.5995 SF3. Saturated liquid, my dear, is it? No, saturated liquid 0.6492. Yes, plus X. HFG. What is HFG? Enthalpy and entropy of vaporization, that is 7.4996. Solve this question, you will get the proper answer of X from here. Solve this question. Let me solve, my dear. 6.5995 minus of 0.6492 divided by 7.4996. Answer we are getting 0.79. Is it? X from here we are getting 0.79 if I am not wrong. Ajay, is it your efficiency? After that, you calculate the value of H3. So you will get the answer H3, HF3 191.8, 191.8 plus of 0.79 into 26, how much? This 2392. Can you please tell me the answer? 2392.1 multiply by 0.79 plus of 191.8. Answer is 2081.56. So in this case, H2, H3, H4 is already given to us. SG is not given. No. It is SFG. Ajay, it's SFG. The enthalpy of the vaporization means it is within the dome, my dear. It is within the dome we are talking about. right? Because if you will take the difference, we are getting 6.555995 minus 0.6492 divided by 7.4996. We are getting 0.79 is the answer, Hemang. Is anything wrong? S2, enthalpy at the inlet of this one is given to us. This is the enthalpy at the inlet of the pump or the outlet of the condenser, and this is SFG, that is 7.4. Enthalpy, this one is coming. How you are getting 0.86? 0.86 is not the answer, is it? Because my calculation is wrong. I have just calculated, not wrong, I have just calculated the same value by 2 times. Are you getting 0.86 or 0.79? What is the correct answer? 0.79 is the correct answer, I think. Sir took SG, that's why. No. SG is not given, na. This is clearly given that enthalpy and entropy of vaporization. Vaporization means within the dome you are talking about, that is HFG or SFG. That's why you are doing the mistake. Okay. So anyway, X we have calculated 0.79, my dear, and after that you will calculate the value of HWT, this one. So in this case we substitute the value. We are getting the value like this, that efficiency will be equal to H2 minus of H3 divided by turbine work, H2 minus of H3 plus of, how much is the heat rejection? H3 minus of H4. This or this term can be cancelled directly, or you will write from here that H2 minus of H3 divided by H2 minus of H4. That's all. Now you get the correct answer. Substitute all the values, you will get the correct answer. What is the value of H2 from here? H2 3375.1, 3375.1, H3 2081.56 divided by H2 3375.1 minus of H1 191.8 percentage efficiency. Now tell me the answer. This is the correct answer. So these small mistakes can create a lot of problem for you, my dear. Minus 2081.56 divided by 3375.1 minus 191.8 is the right answer. 40.63. Yes, 40.64 is the correct answer. Good, absolutely right. Move forward. Question number 21. This is the last question I am going to discuss. After that, Dheeraj sir is coming. Sir, Dheeraj sir, if you are ready, just write in the comment section. This is the last question I am going to discuss. After that, my dear, Dheeraj sir is coming. He is going to discuss very wonderful question of the strength of material. Sir, are you ready? If you are there in the comment section, please write. Over to you, sir. Question number 21, the minimum and maximum temperature of an air standard Brayton cycle. Sir, ready hai kya? Okay. So yes, this is the last question. You need to find the efficiency of the minimum and maximum temperature of an standard Brayton cycle is given to us. Okay. Sir is waiting, so after that he is coming. So efficiency of the regenerative Brayton cycle can be read like this from here. That will be equal to T minimum divided by T maximum, my dear. And it is equal to R raised to gamma minus 1 upon gamma minus of 1. Lot of time this type of question you have solved. What is the T minimum? 300. T maximum, my dear, 1100. After what is R? 6. If I solve this answer, what exactly we all are getting? 40.65 is the correct answer. Not write the approximate approximate answer, नहीं तो वो habit हो जाएगी आपको. Okay. So this is the last question. A specific humidity of the air at 100 kilopascal is 0.15 kg per kg of the dry air. Partial pressure of the vapor in the existing state, my dear. Specific humidity, is it 81? मैंने calculate नहीं किया है. Is it 81.6? I have not calculated this answer. You have calculated, that's why I am going to write the answer. You all are minus of 1 multiply by 300 divide by 1100, 1 minus answer 81.71. Yes, your calculation is wrong. 81.71 is the answer. Is it or not? Yes. 81.76 is the correct answer for it. Yes. Next question. Sir, the specific humidity. Okay. Specific humidity. This one is given to us. That is 0.622 PV divided by barometric reading minus of PV. These type of questions are asked in XC exam. This question I have directly taken from XC so that you can get the idea कि हमको यहाँ तक wait करना है. Sometime in the last, my dear, few important and easy questions are there. So what is the specific humidity? That is 0.015. 0.622. Barometric or vapor pressure I need to know. Barometric reading is 100 kilopascal minus PV I need to know. Can you please tell me the answer? What is the correct answer in this case? If I'll just multiply this, that will be equal to okay. Yes, Ajay. 1.5 minus 0.015 PV will be equal to 0.622 PV. Can you please tell me the answer? Is equal to 1.5. From here, what is the value of PV? That will be the correct answer. Anyone? Write the correct answer fast. 1.5 divided by 0.622 plus of 0.015. That is 2.354 is the correct answer. Is it or not? This is the answer of the last question, whatever we have discussed, my dear. I think all of you are getting the same answer, if I'm not wrong. Is everyone getting the same answer? Yes, 2.354 is the correct answer, Ajay, Hemang. Yes. So this is all about the thermodynamic from myself, from my side. After that, Dheeraj sir is coming. I am going to share the PDF in my Telegram channel. You will get the PDF, right? So I hope you have just enjoyed. Again, if you are having any doubt, any problem, my dear, tonight at 10 p.m. we are again meeting, me and Dheeraj sir, on the same YouTube channel. You join that session. See you again. So thank you all. Over to you, Dheeraj sir. Just a minute. Over to you, sir. Okay. Just a minute. Over to you, sir. Okay. Just a minute. Over to you, sir.
Yes, once again, welcome to you guys on this session. Ajay, good morning. Yes, Hemang. So guys, if you like and share the session so that other students can also join. So already sir have discussed the 22 question. Now I will be discussing the 22 question of SOM. And I feel one more thing I would like to say, guys, like you have just given the gate mechanical paper. So you would have got something that it is not like all the questions are difficult. Like you have seen in strength of material, 50% questions were easy, 50% were something you need to think about. Okay. In machine design, all questions were easy. In production, welding question was easy, casting was easy. Yes. If you talk about that one question from that was difficult, that is related to metrology. So that's why, as I said, guys, it is a mixture. Okay. So all kind of questions will be there. You need to prepare for everything. And difficult kind of questions are difficult for everyone. So don't mind it, don't worry about that. So we are starting the session now. Yes, Tema, good afternoon. Shul, Ajay, We are starting the session, guys. So today we are going to take the question from SOM. I will be taking 22 questions as per the pattern of XC paper. Okay, and they will also be a combination of easy to moderate to difficult. Tonight, sir was saying this session is there, but this is not at 10 p.m. This is at 11 p.m. Okay, so be ready for that. In this session, we will be telling you everything what you can get. Okay, so 11 p.m. will be the time of this session. So be ready for that. Okay. Yes, let's move further, guys. So, guys, one more workshop. If anyone is your junior who is going to prepare for GATE 2024, for those students, this is a free workshop on 7 success mantras from a beginner to topper in GATE 24. 11th February, 7:30 p.m. will be the time. Okay. So after your exam, this session will be there. You can tell to your juniors if they want to attend. This is the very first question. Hemang, Shruth, Ajay, just try to solve it. This is the very first question, and I feel this question everyone will be able to answer very easily. A simply supported beam of length L is subjected to a variable distributed load W. It is given as Wxx, W sine 5 pi x by L. This is the case. And guys, where the distance is measured from the left hand side of the support, it means this is the simply supported beam, and we will be taking distance from here. He is asking you what? The vertical reaction. So if this is point A, this is point B. He is asking you RA, which is equals to RB by symmetry. What will be that value? Manas, answer is B. Ajay is saying answer is B. Yes, guys. The answer for this is B. I already told you that if you have 5 pi x by L, you know answer is going to be W into L upon 5 pi. And I told you this is valid only if N is odd. What is N? This value. If this is odd, this formula is valid. I told you this as a shortcut. Very good, Shruth. बहुत बढ़िया. Yes, बहुत ही बढ़िया. So guys, moving to the second question. As I said, questions are easy to moderate to difficult. Everything difficult will not be there in the paper. So this is similar to XC paper we have make it. Some easy questions, some difficult questions. This type of question have many there in the XC paper. If you will see, every alternate paper have this type of one question from elastic constraint. Okay, so these formulas are very important. This is the relationship between the elastic constant. Let us see how many of you give the right answer. Difficult question will also come. Easy to moderate to difficult. Hemang is saying D. Concept is the success is saying D. Ajay Krishnan is saying D. Shruth is saying D. बहुत ही बढ़िया. So guys, do like and share the session. The answer is going to be D. You know that what are the elastic constant relation? E is 2g into 1 plus mu. E is equal to 3k into 1 minus 2 mu. E is equal to 9 kg by 3k plus g. Okay, so remember these relations which will help you. This is a good question now. Very good, Manas. This is a good question now from principal stress and strain. An element shown below is subjected to stresses 5, 3 and 1. You can see this. 5, this is sigma xx is 5, sigma yy is 3 and tau hy is 1. This is given to you. And you need to answer the principal stresses and their direction. Principal stresses and their direction. Okay. So what do you need to find out? You need to find out sigma 1, sigma 2 and theta p. Yes, these are the three things you need to find out. Sir, we have only free vibration in solid mechanics, right? Yes, Manas, we are having free vibrations and that also single degree of freedom system. Okay. And you are also having engineering mechanics. Okay, engineering mechanics is also there. But I have kept only strength of material question in this. Okay, but engineering mechanics is also there. Okay, so there is engineering mechanics plus SOM plus vibration. And that I am going to take a separate session also on Friday. On Friday, I will be taking 22 questions from these three. based on the requirement of the paper. Okay, so be ready for that. Solve this question, guys. You need to find out sigma 1, 2. You know the formula for sigma 1, comma 2 as xx plus yy by 2 plus minus xx minus yy by 2 plus square plus tau xy plus square. Solve it and get the answer. Okay, Manas is saying the answer to be B. What about others? Should there is no such fixed distribution. There is no such fixed distribution. Okay, but yes, major part is SOM. You can say 60 to 70% will be SOM. Okay, concept is the success is also saying B. Okay, guys. Truth is also saying B. Okay. Okay, why not A? Why not A? Do you remember the formula? I feel you forget everything. Dear, that's correct. Sigma 1, sigma 2 values you have calculated very easily. Sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 ka square plus tau xy ka square. This will give you the value of sigma 1 and sigma 2. And you will be getting the value 5.41, 2.58. 5.41 and 2.58. That is correct. Then you will be finding out tangent to theta p. That is tau xy by sigma xx minus sigma yy by 2. If you see here, shear is like this. Okay. So this shear we will consider it as negative shear. So when you will be considering it as negative shear, you will be getting 2 theta p as minus 45 degree and theta p will be 22.5. Yes, and that kind of mistake, that's why this option was given. A is the correct answer. So this type of mistake you have to be aware of and you need to avoid and eliminate these kind of things. Otherwise, the marks will be deducted. Moving to the next question. This is from SFD BMD. It is a wonderful question, guys, and this is MSQ. This is MSQ. Try to solve it. This is UDL. Okay, UDL in the entire beam. First of all, find out the support reaction. Then I will tell you SFD BMD also. Now we are very much prepared for SFD BMD. Very easily you can make it. Okay. This type of questions are very good, and I will say when you will find out the support reaction, this is Rn, this is Rn. So this is overhanging beam. You need to apply the conventional procedure, that is Rn plus Rn is equals to total UDL is 1500 for a length of 2 meters. 1500 into 2 newtons. This is one equation. Then take summation moment of L to be 0 and find out the value of RL and Rn. You have to do the calculations. Yes. This is MSQ, so more than one option can be correct. This is MSQ, so more than one option can be correct. Okay. Hemant, Manas, Ajay, Shruth. Try to solve it. Just find out the support reaction. Then I will help you. Okay, Manas is saying A is correct. Means you have calculated the support reactions. Yes, that is correct. When you will be finding out RL, it is coming out to be 1 kilonewton. Rm will be 2 kilonewton. That is correct. Very good, Hemant. Very good, Hemant. बहुत ही बढ़िया. Now, my dear, for other options, you need to make shear force diagram and bending moment diagram. Once you get these values, you can very easily make SFD and BMD. How we can make it? Let us see. You know that first of all I will be taking a section to the left hand side of the section. You know that this is positive shear force, this is negative shear force. So this is positive means we will be having an upward jump. We will be having an upward jump of 1000 Newton. So this is going to be 1000 Newton. Okay. Then you know after that it is going to be a UDL. So for UDL SFD will be of this shape. And it is for 1.5 meter 1500. 1500 into 1.5. Okay. So you will be reaching to some point here. And I feel this value after the calculation what you will be getting, you will be getting as minus 1150. 1250. And then it is a jump of 2000 which will make you reach to 750. And then you will be having this. Sorry, this. I feel everybody got it. SFD. Okay, some of you have already given the answer also. This is going to be the SFD. Now if we are going for making the bending moment diagram, my dear. So you know that how the bending moment diagram will be coming as it is creating hogging. So it is inclined line. I will be having a parabola. And that parabola will be of this shape. Why? Because the magnitude of shear force is increasing. And then here bending moment will be maximum. So this is going to be the BM. So bending moment is 0 at this point, 0 at this point, 0 at this point. Okay? Yes. So answer will be, let us see. Bending moment is 0 at the point L and a point in between L and N. The bending moment is 0 at point L and N only. The shear force is 0 at point L and L and N. That is wrong. So answer is A and B. Ajay, why you changed? Answer will be A and B. Okay. Yes, Manas, you got it. Hemang, you got it. Manas, Hemang, Ajay, Shrut. Concept is the success. Please tell me. Yes, please tell me, guys. Moving further, guys. Next question. You can see this type of question also was there in the mechanical paper. Okay, guys, if any one of you want to talk about the paper with me after this session, you can talk to me. Like Manas, I didn't get anything from your side about the paper. Ajay also. Shrut, I have already talked to. Hemang, you also. So the true stress at fracture of a tensile tested specimen having an initial diameter of 13 mm. This is true stress 700 MPa. If the diameter of specimen at fracture means final diameter, then the engineering stresses. So you know engineering stress is defined as force butting 5 by 4 d naught का square, whereas true stress is force butting 5 by 4 at the fracture it will be df का square, because we are knowing the value at fracture point. So at fracture point this is going to be the value. So this is given to us. This is given to us as 700 MPa. From this you can get the value of P. Put this value here, you will get engineering stress. So this is a question from stress and strain diagram. Solve this and let us see how many of you give the right answer. This is our question number 5. This is our question number 5 and we are going to do 22 questions. Just solve it. Just solve it, guys. Very good. Ajay have given the answer as 414.2. Manas, Shrut. Very good, Hemang. The answer for this is 414.2. 414.2. This is engineering stress. Okay. Very good, guys. Moving to the next question. Next question is saying the principal stress values. Sigma 1 as 120. Sigma 2 as minus 50. Sigma 3 as 10. Yes. Very good, Manas. Solve this question, guys. We need to find out the maximum shear stress. I feel you know when three principal stresses are given, he is asking about in plane or absolute. In plane or absolute. What do you feel? In plane or absolute? What do you feel? In plane or absolute? What do you feel? Yes. Obviously absolute. Obviously absolute. Obviously absolute. So guys, you need to find out absolute tau max. Find out, then you know I feel the formula for that. So here this question I have taken just to remind you about absolute and in plane. Okay. Tell me the right answer. So the answer is one value out of these three. The maximum is 85. 85 MB. Okay. Very good, guys. Next question, guys. Question number 6. Question number 6 is a metallic bar of uniform cross section with specific weight. Specific weight is gamma. 100 kilonewton per meter cube. Is hung vertically down. The length and Young's modulus. Okay, they are given elongation of the bar. Okay, this type of question you have seen in gate mechanical also. He is asking about elongation of the bar. Okay, so elongation of the bar you need to find out. This is given as a metallic bar of uniform cross section with a specific weight. Specific weight means rho into G is given to you as 100 kilonewton per meter cube. If you remember, the formula for delta is rho G L square upon 2E. That will be the answer. Solve it. Very good, students. What would be the answer? The next question is again from SFD BMD. Okay, concept is the success is saying 2.5 mm, which is correct answer. Okay, so for strain energy you need to integrate because of self weight. Self weight increase when we go from bottom to top. That is why. Okay, fine. Very good, Hemant. Very good, Ajay. Moving to the next question, guys. This is next question. A beam is loaded as shown in figure. The bending moment in Newton meter at point R. You need to find out bending moment at this point. Okay, you need to tell the bending moment at this point. Bending moment at this point. Yes. For that you need to see the effect of this 10 kilonewton by making 10 kilonewton downward, 10 kilonewton upward. This and this, they will be making a couple like this. Then you know this have two components. One is downward, other is upward. This is 6 sin 30. This is 6 cos 30. Using this principle of superposition, you will be finding out the support reaction at S, support reaction at E. Okay, after getting it, the bending moment at R can be written as RS into this distance 2 meters. That will be your answer. Because you know bending moment at a point or in section can be seen either from left or from the right hand side of the section. Okay? Yes, yes, yes. So guys, just solve it and get the answer. Solve it and get the answer. Solve it and get the answer. This is question number 8. Question number 8. Solve it, guys. Solve it. Manas, Hemang. If you see the beam, this is RP. This is RS. Here there is a force of 10 kilonewton and a moment of 10 into 1. And on the other hand, there is a force. If this is required because horizontal reaction will be balanced, that we need not to worry about. 6 sin 30. You will find out the support reaction at P and support reaction at S. What you are getting, guys? Yes, anybody? Anybody? You will get this to be 7 kilonewton. This to be 6 kilonewton. Because this is 3. So 10 plus 3 is 13. Okay? Very good, guys. So after getting these values, you will be getting the bending moment at R to be 7 into 2. The value is 14. And if this is in kilonewton, distance is in meter. He is asking in Newton meter. Take care of this also in numerical answer type questions. Okay? Take care of this also in numerical answer type question. Units. Otherwise you will lose the marks. Okay? Yes. So moving further, guys, to the next question. So guys, Sanjay, here we are having all the level of questions because in exam you are not getting all the question difficult. Okay, so we need to take care of all. Minus the answer, okay. Are we talking about this? The answer is not 0, the answer is 14. Because what he is asking is bending moment at R. What is bending moment at R? This force into this distance. Remember, bending moment is force into perpendicular distance. No? So this to the either you will see to the right hand side or you will check from the left hand side. Bending moment at a section is defined as the algebraic sum of all the moments either to the left or to the right hand side of the section. Okay, so you need to take either left or right. Okay, yes. Moving further, guys. So this question here I have made based on the level of paper like they are asking. Okay, so I have taken care of that. This type of question have been there in PI paper also, XC paper also. Otherwise, you have seen I have never did that kind of question in mechanical. But in XC they are asking, in PI they are asking, so I have to take. Because this is particularly for XC, this is not we are playing truth and dare. Okay? Fine. A beam is subjected to an inclined concentrated load. Neglect the weight of the beam, the correct free body diagram. So this is very easy question, but this was asked in XC 2 times. That's why I have taken it. This is very easy. You just need to see which support gives which type of reaction. So answer will be B for this. Now, this is a good question. This is a good question. A bar of rectangular cross section of area 50 mm square. Area is 50 mm square. Is pulled from both the sides by equal forces of 100 Newton. The shear stress is MPa. So he is asking shear stress at this place. Let us see how many of you are able to do this. Let us see how many of you are able to do this. Solve it, guys. Solve it. This is question number 9. Sorry, 10. Question number 10. This is from stress on an oblique plane. This is from stress on an oblique plane. Like we have a member like this. This is the plane. You know this angle is theta. We are given this angle 45. So theta will also be 45 because this angle is 90. So if you remember, on this oblique plane we derived the expression for normal and shear stress. Normal stress is P by A cos square theta. Shear stress is P by 2A sin 2 theta. Okay. So if we are going to have this, what is P? P is 100. Divide by 2 into 50. And what is sin 2 theta? Sin 90, which is 1. Answer will be 1 Newton per mm square. Moving further, guys. Once again from SFT BMD topic. This is the cantilever being given, but here they are asking you about the bending stresses. Okay. This is the point P. You need to answer the bending stress value at P. Okay. So you know that first of all you need to find out the bending moment at P. After getting that, bending stress is, it is given as 32 m. So not 32 m, because it is having the section of rectangle or square. So bending stress is m y max upon INA. That you need to tell at P only. Here y max, because the section given is a square section. So INA is A4 by 12. Y max is A by 2. Use this expression and give the answer. नहीं भाई, ऐसे ही तो लिया था यार. We have considered it in this way only. In uniaxial loading, when we derived, we have taken in this way only. What you are saying counterclockwise was in the case of combined loading we have taken. You forget about. Okay. Find out the normal stress at point P. This question I have taken to tell you a very important point which students are doing mistake in the paper. Just solve it. Just solve it, guys. Just solve it. Solve it, guys. अरे भाई, first of all, if you have a cantilever beam subjected to UDL, this is W kilonewton per meter. Then you know the maximum bending moment will be coming here, which is equal to WL square by 2. W into L into L by 2. So you will be finding out it as 100 into 1 square upon 2. This will be coming out to be 50 Newton meter. Okay. Now my dear, the area is given as 10 cross 10. So 50 into Y max will be 5. I and A 4 by 12. 5 4 by 12. This will give you the value of bending stress. Okay, Ajay is saying the answer to be 0.3. What about others? I feel the answer will be coming out to be 300 MPa. It will be coming out to be 300 MPa. Yes. Are you getting 300 MPa? Dear, you forget that this is in Newton meter. So you didn't multiply it with 100. This is mm4 and this is mm. So this meter need to be converted. So because of that, you need to multiply it with the 1000, which you forget, Ajay. Okay. So when you will multiply it with 1000, then the answer will be 300 MPa. But here is the twist. No doubt, those students whose fundamentals are correct, who are taking care of the units, they will reach to this answer. But if you see, by looking at the loading, can you tell is it sagging or hogging? If you see, the beam is going to deflect like that. So it is going to be hogging. And for hogging, this fiber is in tension or compression. This fiber is in tension. So the answer will be plus 300. So that also you need to take care of, that plus aayega ki minus aayega. Will it be plus or negative? That also needs to be taken. Okay? That also you need to take care of. So if that loading is downward, it's hogging going on, you know, compression will be here, tension will be here. If they ask here at Q, the answer will be minus 300. That kind of twist can be there in the question. Okay? Very good. Moving to the next question, guys. So as I said, all the types of questions will come: easy, moderate, difficult. A 300 mm long copper wire of uniform cross section is pulled in tension. Pulled in tension. So that a maximum tensile stress of 270 MPa will come within the wire. The entire deformation of the wire remains linearly elastic. The elastic modulus of copper will be 100 GPa. The resultant elongation in M. You need to find out the resultant elongation. You need to find out resultant elongation. Okay? Yes, E is given to you. Try to solve it. This is not a difficult question. It is easy question. I feel you know delta L is PL upon AE. They have given you the value of P by A. Sigma L upon E. Sigma is given to you. Okay, in uniaxial loading, you know tensile stress is equal at each fiber. Solve it and get the answer. This is just to confuse you, nothing more than that. Next question will be from Mohr circle. We have completed 12 questions. Very good, very good. The answer will be 0.81. So you can see last question was slightly moderate type of. This is easy. Next is from Mohr circle. Yes, Manas, are you there or not? This is from Mohr circle. This time I will not help you. Solve it. For a two-dimensional state of stress defined as sigma xx, sigma yy, tau xy is x. The Mohr circle will be sigma xx, sigma yy, tau x. Try to solve it, guys. You need to tell about center and radius. हाँ बिल्कुल 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 कई बार होता भी है लाइक इस बार जो क्वेश्चन था that was related to the engineering ultimate stress. Even I have not seen there for the first attempt that whether true stress is given because the data I got it was in the raw form. Okay, so that is why that kind of mistakes are going to happen in the exam. Hemang is saying the answer to be A for this. Yes. You know that the center of Mohr circle is sigma star comma 0. What is sigma star? Sigma xx plus sigma yy by 2. Okay. What is sigma xx? S plus S by 2. So center is S comma 0. So either A or C can be the answer. B and D are rejected. Then radius. Radius. For radius, what you need to do? Radius is tau max actually. So what is tau max? Sigma xx minus sigma yy by 2 ka square plus tau ka square. The answer will be S again. So answer will be A for this. A is the right answer. Okay, moving further. Next question, guys. This is from theory of physics. This is from theory of physics. This is our question number, I believe 15. Question number 15 of SOM. A specimen of steel has a yield strength of 700 MPa. He is saying principal stresses are equal. Now you need to find out factor of safety from MDET. Just solve it and get the answer. हाँ, okay, 14 है तो 14 लिख देते हैं. Fine. Yes. Solve it. Solve it. And do like and share the session, guys. We are still left with 14 plus 8. 8 questions. You know, I feel MDET maximum distortion energy theory, which is sigma 1 square, sigma 2 square, minus sigma 1 sigma 2, HYT square upon N square. You need to find out N from here. Okay, Hemang is saying answer is 1.4. Manas is also saying the answer is 1.4. Moving to question number 15 now. A square cross section wooden column of length 3140 mm is pinned at both ends. For the wood, Young's modulus is 12 GPa and allowable compressive stress is 12 MPa. The column needs to support an axial compressive load of 200 kN. Using a factor of safety of 2 in the computation of Euler's buckling load, the minimum cross-section area required is. This is a question from column actually. You all know that the formula for buckling load is pi square EI minimum upon LE square. Okay, they have given the square section, so you will be writing the load at support should be less than equals to buckling load but a factor of safety. Okay, so they have given you this as 200 kilonewton less than equals to pi square EI minimum upon L square. Factor of safety is given to you. From that, you can very easily find out the value of A. Square cross section is there. Then area will be A square. How I can find out? Because I minimum will be A4 by 12. Solve this question and get the answer. This is from column. I have covered all the topics. This is from column. Theory of failure you have seen, column you have seen. Solve it and get the answer. Solve this and get the answer. Solve this and get the answer, guys. Solve this and get the answer, guys. Yes. Little bit lengthy, but it is a good question. Ajay, answer will be 1.4 for the previous question. You need to find out the area. Everybody. E is given as 12 GPa. Okay. Length is given as 3140. It is mentioned pinned at both ends. It is mentioned pinned at both ends. Okay. Ajay, this is the value for what? Is this the value for area? Is this the value for area, guys? Okay. How you will do this? 200 kilonewton means 10 to the power 3. When factor of safety will come here, it will multiply by 2. Okay, it is less than equals to pi square into 12 GPa. 12, I am writing the units. 12 GPa. Then I minimum is A4 by 12. Then LE is 3140. By solving, this is having the units of Newton now. This is mm4, mm square. So it should be 12 into 10 to the power 3 Newton per mm square. Doing this will give you the value of A4. Then you can find out A square. That is your answer. Nahi, Ajay, why 2? When both ends are hinged, it will be 3140 only, na? Entire length will be affected. Okay? Yes. So guys, the answer will be coming out to be, I feel, actually A4 is coming out to be 4 into 10 to the power 8 mm4. Now find out A square from that. I think you guys have done some calculation mistake. Correct it and tell me the answer. This very good. The answer is 20,000 mm square. That is right answer. Okay, guys. Moving to the next question. This was question number 15. Very good, Manas. That is in the range. Well in the range. Moving further to question number 16 now. 6 more left. Length, width and thickness are given. For the material, Young's modulus is this. Yield strength is this. Poisson ratio is this. When the plate is subjected to longitudinal tensile stress of 70 MPa, the increase in the volume is, you need to apply the volumetric strain formula. 1 minus 2 mu by E into sigma xx plus sigma yy plus sigma zz. That will be the formula applicable. Okay? And they have given sigma yy and sigma zz to be 0 because uniaxial tension is applied. Use this formula, you will get the change in volume. Okay? This is question number 16. Next question will be from once again. Yes, Manas, I understood that. But that kind of mistake here, you need to avoid now. Already one paper you have given for gate. You must get an idea. This is the mistakes we are doing. So dear, if you will closely see the paper, no? Then you will get to know only 2 to 3 questions were there, which you can say that problem should be there. Otherwise, it is just the hype of the paper which become. Okay? So you need to take care of that. Every year this happens. Okay, whenever some 1 to 2 questions are like in 2019, one question came from thick cylinder. But there was no use of thick cylinder. Okay? Solve it. Solve this, guys. Solve this. No, Hemang. Please check it again. Poisson ratio is this. Young's modulus is this. अरे भाई, length, width and thickness. This will be the loading. So one dimension will be 400 and one will be 30. Okay, length is 400. I feel you have kept the wrong values. Okay. हाँ मानस, ये बिल्कुल आपने सही बात कही. पेपर में प्रोडक्शन के क्वेश्चन वैसे नहीं है. प्रोडक्शन में कास्टिंग थ्योरी क्वेश्चन था, वेल्डिंग थ्योरी क्वेश्चन था और कंप्यूटर इंटीग्रेटेड मैन्युफैक्चरिंग से बीएलयू का क्वेश्चन था. ठीक है. अब उसमें जो उन्होंने पूछा था वो कॉमन सेंस वाली चीज थी कि भाई एक स्टेप के बाद तो आपको चेंज कर पाओगे. तो उन्होंने यही तो पूछा था नंबर ऑफ स्टेप्स कितने होंगे. तो बस पूछने का तरीका अलग था. ठीक है. तो वो आसान क्वेश्चन था सिर्फ का. और इसके अलावा अगर हम देखें तो एक क्वेश्चन बस वो फीड रेट वाला थोड़ा डिफिकल्ट था. वो थोड़ा सा लेंथी टाइप का क्वेश्चन था. अदरवाइज अगर आप देखें तो पूरे क्वेश्चन में एक मेट्रोलॉजी का भी लेंथी क्वेश्चन था जिसमें 6 सिग्मा था. उसमें इंडस्ट्रियल का कॉन्सेप्ट यूज हो रहा था 6 सिग्मा और वो क्वेश्चन मेट्रोलॉजी का था. ठीक है. तो डोंट वरी, मैं आपको सभी क्वेश्चंस के आंसर देने वाला हूं. पर वो सभी के लिए था यार, वो सिर्फ आपके लिए नहीं था ना, वो सभी के लिए था. तो आप उसको ये कह सकते हो कि जो मेहनत आपने जिस डायरेक्शन में की, पर ये किसी को भी नहीं पता था. ऐसा नहीं कि ये आपके लिए था, सभी लोग वही पढ़ रहे थे जो आप पढ़ रहे थे. आप किसी से पूछना कोई थ्योरी पढ़ रहा था क्या? नहीं, सब लोग वही पढ़ रहे थे जो आप पढ़ रहे थे. और हम लोगों ने तो फिर भी ट्राई किया कि हर एक सिरे को छुए. बहुत सारे बच्चों ने तो सिम को टच भी नहीं किया था। आपको मैंने मटेरियल साइज पढ़ाया, लीवर रूल से क्वेश्चन आया, मटेरियल साइज पढ़ाया ही नहीं जाता काफी सारी जगह। तो यू टॉट यू वर इवन इवन मटेरियल साइज के मैराथन में भी मैंने लीवर रूल पढ़ाया था, लीवर रूल से क्वेश्चन। मानस वो क्वेश्चन मेरे पास पूरा आया नहीं, पूरा देखकर मैं बता पाऊंगा, ठीक है। पर लीवर रूल वाला मटेरियल साइंस का क्वेश्चन कितना आसान था। और वॉल्यूमेट्रिक जो वो था, वॉल्यूम डेंसिटी का क्वेश्चन, क्या वो आपको फॉर्मूला नहीं बताया गया था? बिल्कुल बताया गया था, क्वेश्चन भी कराए थे। और आप इकलौते होंगे जिन्होंने उसके क्वेश्चन क्लास में किए थे, कोई नहीं कराता उसके क्वेश्चन, ठीक है। तो आप अगर उस चीज को देखें तो आया सब कुछ वही से जो आपको पढ़ाया गया था, ऐसा कुछ नहीं था जो आपको पढ़ाया नहीं गया। बट द पॉइंट इज वहां से नहीं आया जहां से हर साल आता था, ये बिल्कुल सही बात। तो इसको जब आप सोल्व करेंगे तो व्हाट यू विल गेट द आंसर एज 1600। मुझे पता है मैकेनिकल वाले सारे इस बात से भरे बैठे हैं कि सर जो पढ़ के गए वो कम आया, पर जो पढ़ाया गया था आया सब उसी में से है। इसका मतलब आपने सब नहीं पढ़ा जो पढ़ाया गया। ओके, आंसर विल बी 1600 mm क्यूब। तो आई फील हेमंत का आंसर नियर बाय है। ओके, 1600 mm क्यूब आएगा आंसर। क्लियर है? चलिए कोई बात नहीं, हम बात करेंगे इस पर। मानस ये ठीक है, अभी आप पेपर दे दीजिए इस बार, फिर उसके बाद फिर डिटेल में बैठ के बात करेंगे, ठीक है। आपको मैं बहुत कुछ बताऊंगा जो आपके काम आ सकता है। मूविंग फर्दर टू क्वेश्चन नंबर 17। A metallic rod of diameter D2 D naught is subjected to the tensile test. The engineering stress and the true stress. Engineering stress 800 MPa. True stress 900 MPa. The ratio of rod diameter dt to the initial diameter. Engineering stress is लोड बटे ओरिजिनल एरिया, लोड बटे पाई बाय 4 ओरिजिनल डायमीटर का स्क्वायर, टू इज लोड बटे फाइनल एरिया, बिकॉज फ्रैक्चर पे बात हो रही है, पाई बाय 4 डीएफ का स्क्वायर। यू रीड द रेशियो ऑफ डीएफ टू डी नॉट, डी नॉट टू डीएफ। डियर, फॉर पीआई hardly 1500 students are there who are giving the exam. Okay, so actually we have planned one session that is from production question. Okay, so that I feel will be on Thursday or Friday. I will announce about that. One session only for production we have planned. Okay, so you need to find out d naught by df, solve it. And these questions what I am doing, the similar questions are coming from SOM also Teju in PI paper. You can check it. Even 3 to 4 questions I have taken from previous year's PI in this. Okay, because in this session we want to cover for both PI and XC. The answer for this question is 0.942. Okay, moving further. Question number 18. Which one is correct? So after this, one more question from column. Okay, they were asking final by initial. Sorry. Fine. What about this? What about this? Yes, Ashutosh, Hemant, Ajay, Manas, Teju. You need to find out the longitudinal spring. That is sigma xx by e. This is the formula. But sigma x is tensile, sigma yy is compressive. So the answer will be C for this. Easy question, but this type of question will be there in exam. This is once again from the column. The last I came here to ask for doubts, sir. In BLU, always gear ratio less than 1. We should take some. No, it is not like that. Even if you see there is a question, Teju, from gate only, there you see gear ratio is given as 4. It is always more than 1. Okay, it is always given. Okay, sorry. You are saying in the question 1/4 it was given. Was it like that? Because we are defining pitch but a NS. Are you talking about that question now? Yes. Do one thing, Teju. Let's do one thing. We are here at question number 20th. Let me solve 2 more questions. Okay, then we will connect on mobile. Okay, then we will connect on phone. Because other students may not be interested in production. Okay. So, like whenever I have named production, you can see how Manas was angry on production. Okay. So, people are very unhappy from the paper maker. But guys, I have not made the paper. So, I can understand. भरे बैठे मैकेनिकल वाले इस तरह क्या पूछ लिया ये. But मैंने नहीं बनाया पेपर भाई. And neither I am saying कि whatever they have done is correct. No, actually that kind of paper was not expected. So, okay. You need to find out the buckling load. Pi square EI upon LE square. Okay? Yes. So the answer will be 4935. 4935 Newton. Fine. A is the right answer. So guys, now rest 2 question I have taken from gate 23 paper. Rest 2 question I have taken from gate 23 paper. Okay. To cover this type actually. To cover this type. This was the question in which you were asked the stiffness. P was the load, EI was the rigidity. You know that deflection at point A is defined as PL cube upon 3EI. And you already know that stiffness is defined as force but a deflection. So to tell you this concept, I have considered this question also. Hemant, but from last 2 years, 22 and 23, they are major ones. Before that, it was not like these 2 years. These 2 years are very, very, you can say, twisting. Okay? Yes, Ajay, that is what I am telling you. In gate, they are making you means in such a way that you will be doing the mistake very easily. Even they are making the options like that. That's great, Teju. I was not expecting that. That's what I said. In the gate, making mistake is very common, very common. Okay. So the answer for this is B. But the problem is the students who will not make the mistake, they will be the rising stars. Okay. So the answer is P by PL cube upon 3EI. The answer will be 3EI upon L cube. Okay. So the last question. This is once again from theory of failure MSQ. You know sigma 1 is plus 70. Sigma 2 is minus 70. Sigma 3 is 0. So this is the case of opposite nature of principal stresses. You need to tell the statements for MPST and MSST. This question also you have done it wrong. That's why for those things only your test series were there. Test series were there to make you prepare for all those things. But definitely, as I said, you guys must get some learnings from this exam. Dear, don't worry. many students are not able to succeed in the first attempt, but they do wonder in the second attempt. So if you have patience, if you can prepare, if you have all kind of supports, you can prepare it well. And still I will say, if you feel your preparation was good, attempt was not good, then you have engineering services, okay, maybe difficult, bar not difficult, ISRO not difficult, SPCL can be done, okay. So still you have a lot of opportunities. So don't leave the preparation now. Work on the learnings. Like you have seen where you are making the mistake, just work on that. In production, if you are facing difficulty, go for it. If SOM you are facing difficulty, go for it. Okay, so bar ISRO are still there. They are very good options. Okay. So guys, if you see this, when you will go for MPST, the yield strength is 100 MPa, so you will say 70 is less than or equals to 100 by n. Factor of safety will be coming more than 1, it means the material or component is going to be safe. On the other hand, for MSST, sigma 1 minus sigma 2 is less than or equals to SYT by n. When you will be doing this, 70 minus of minus 70 is less than or equals to SYT by n. Factor of safety will be coming out to be less than 1. It means fail. So the correct answer is, according to maximum normal stress theory, predicts the material does not fail. That's correct. MSST predicts A and D will be the right answer. Okay. So guys, once again I am saying, don't worry. Give your exam on Saturday. I don't want to waste your time right now. And after your exam, talk to me. Bologe, halke hoge, I will give you some suggestions, because it is not like here these kind of things happen. Every exam is having some twist. Okay, this also have. These twists may be in the favor of some students, maybe in not the favor of some students. But this happens. This is a journey, no? So if you see, you can talk to me, you can ask your doubts. I will tell you majority of the options which will help you. I will be having a lot of options which you are not aware of, okay? Because I had experience of more than 10 plus years, so there are many students I know who were not able to do well in GATE, but they are right now working in good companies because there are many opportunities about which you do not know even. So you may be saying, sir, why you have not tell us that before? I don't want it to distract you. Now you have already given the GATE, appear for this Saturday GATE. Then I will tell you about other opportunities also, like bar ISRO, you know that. There are some others also. For a masters also there are some opportunities. Okay. So I will tell you all things. Don't worry about it. Okay. Sir, PI, what is the minimum score required? Dear, actually it is not like that for minimum score. I feel that if you are coming under top 100 and 200, you have chances in any IIT. For IIT Bombay particularly, under 100, not more than that. Even under 100 is not surety. Like last year our student Stagnik had 18 rank. He got selected there. Okay. So I would like to say, give your maximum. Don't think like that. Give your maximum, okay? Because you don't know how the paper will come. Sir, less students means score required will be reduced. Here, actually, less student means less competition. So it will be easier to get in. Okay? But the point is, IITs take, there is a formula. About that also I will make a video if you want. Okay? So there is a formula based on which the GATE score are coming, and 70% weightage is given to the GATE score, 30% will be interview. Don't worry, for that also I will tell you about the formula that you can see in your admit card also, score card also. That kind of formulas are always mentioned. Okay, I will share it with you. Yes, number of students are something on which it depends. Okay, even minimum cutoff is also something on which it depends. So we cannot predict anything before because it depends on the number of candidates, it depends on the cutoff, okay, it depends on the average marks, that is the total number of marks divided by total number of students. So there are many factors on which it depends. Thanks. And I feel here, if you see the paper in strength of material, in machine design, in theory of machines, there was no question where you say that, sir, is there any difficulty? They were common only. The difficulty things only came in production because of some questions which were not from the portion which every year they were asked. So that can happen. Okay, no problem. And that is for everyone. But still here, if you will see closely, then you will find material science part which was taught to you. If you have done it correctly, 4 marks you can easily crack from that. Okay, lever rule and volume density. Even in marathon that I have told. If you have done the BLU part, 2 marks from there also. Okay, metrology plus industrial combined question was there, 6 sigma. That yes, it is a lengthy question. But if you are aware of concept, you can do that. Okay, so with this I will say goodbye right now. But don't worry, I will be taking some questions for production separately. Teju, don't worry. But dear, you just tell me that I have told you or not. The question which was asked in SOM, you all tell me that question was there in the SOM that I have covered in the class or not. Please tell me that. Have I covered this in the class or not? Please tell me that. I have covered this separately or not? You will not find this in notes of any other teachers. I have covered this separately or not? Tell me that. Yes, that's what I am saying. There is nothing which was not covered for you. Yes, you may not have revised everything. You may be thinking it's a crime. अरे नहीं आना होता तो मैं कराता ही क्यों? If I have done it, there are chances. That's why I have done it. Yes, it is less important, but question can come because it is in syllabus. Okay, but don't worry, guys. Exam हो चुका है. Now what we can do? We can help you out. Don't worry, I am always there for you. Just give your exam of XC. Talk to me separately one by one. For different students, some may be having financial issues, some may not be having financial issues. So based on your condition, I will guide you what is going to be best for you. Okay? So just talk to me after this exam. Give XC or PI, whatever you are giving. After that, talk to me. Okay? So I have given my number to all of you, or you can ask. That graph was asked, but what is that graph meaning? You know that here the pressure is going to be maximum because of which longitudinal stress is coming. So longitudinal stress is going to be constant at any section. And centripetal stress, and circumferential stress will increase. At this point, they will become equal. So it was very, very easy. Very, very easy. Okay. Sure, Ashutosh. In the Telegram channel, I will provide you. Okay. So in the Telegram channel, you ask me, there I will provide you. You know the mechanical by Real Sardana. Or if you want to write, I am dictating, you can write 7046795443. Okay. So goodbye guys for this session. Thanks for joining. Goodbye.